I said that when you have something like this, remember, this is a technique, right? We are applying linear first order differential equation technique to determine the general solution of this differential equation. I said that even when you apply other techniques, within the technique that you are applying, you can also apply other techniques. Like for example, like I said, this is the linear first order differential equation. So now what technique are we going to apply to integrate this? Now we're going to have to apply integration by parts, or we have to apply u substitution, or if partial it is there, we also apply it. But having a look at this, how can we integrate this? Which method are we going to use? Are we going to use the direct integration? Are we going to use by parts? So by looking at this, né, we're going to use the u substitution. But I'm sure you want to ask me how, like, why are we even using u substitution? I said that when you have a variable like this, the other one, it is x to the power of 2. The other one, it is just x. Just know you apply u substitution. That's the technique. That's the, yes? Nkuna?
No.
Oh, okay.
Oh, sorry.
Oh, all right, no problem. So, here we're gonna apply u substitution. Like I said, the reason why we apply u substitution is because the other x is to the power of 2, the other x is just x. This is the simplest way to see whether you apply u substitution or not. Okay? And be careful when you are multiplying two functions. I get it. Well, normally when you have composite function, you'd want to use substitution. When you multiply two functions, you'd want to use by parts. If by parts doesn't work, then use substitution. But if you see that by parts can work, it's fine, it's still applicable. But this is the easiest way. So now, using u substitution, I'm going to let the x with high degree to be my u, right? So that means I'm going to have to let u to be my x squared, not u to be x. And don't say e to the power of x, no, because we want to cancel x. That's the reason why we want to let u to be equals to x squared. And then when we differentiate this equation, we're going to say du over dx is going to be, we know it's going to be 2x, right? Now I want to make not dy. I want to make dx the subject of formula from this equation. So how am I going to do that? I can see that I can cross multiply. It's going to be dx is going to be equals to 1 over 2x du. You can manipulate it however you want to, as long as you know how to manipulate this, so that your dx can be the subject of the formula. Now we go back to our equation. We're going to substitute, right? We are not done yet. So we're going to write this side as it is. So here we have y multiplied by e to the power of x squared is equals to the integral of what? E to the power of, remember we said x squared is equals to u. So that means here we're going to have e to the power of u. And therefore, okay, I can repeat my x as it is. But what is dx? We said that dx is going to be 1 over 2x multiplied by du. That's what we did, right? Now let's continue to solve our equation. So here we have y multiplied by e to the power of x squared. Now this x will multiply with this x, meaning they cancel off, right? And then after these cancel off, now we're going to have the integral of e to the power of u 1 over 2. Let me take my constant already outside, right? Because I'm going to left with 1 over 2 du. Now I'm integrating respect to u. But remember, we are not looking for, we are not using u, we are using x. So I'm going to substitute my x back onto the equation. Y multiplied by e to the power of x squared is going to be equals to 1 over 2 integral of e to the power of x dx, right? But it's fine. I know some of you guys do it like this so that you don't want to feel confused or you don't want to make mistakes, okay? Actually, we can just do it like this. Let me show you. You can just say, because e to the power of u du, integrate this in respect to u. So let us integrate it. So what is integration of e to the power of u? is going to be e to the power of u, remember that, plus c, which is now our constant. But remember, we are not working with this variable, we are working with x. So we're going to do a back substitution. So that means here we're going to have 1 over 2 e to the power, remember we said u, it is actually x squared plus c. And look, let me tell you this. This is the final answer. This is where you leave your answer. Ne? You leave your answer if they say to you, express your final answer implicitly. This is implicit form, okay? This is what we call the implicit form. But if you need to leave your answer in explicit form, then you have to make y subject of the formula. How? You're going to divide both sides by e to the power of x squared. Actually, this is the final answer. We are done integrating. Just that now we simplify, or we just make y subject of the formula in explicit. And most of the time, they would want you to leave your final answer in explicit form, okay? Explicitly. So that means this is equals to, right? So we're going to divide both sides by e to the power of x squared. And then there we're going to left with y. And then e to the power of x squared will cancel e to the power of x squared. And then we're going to left with 1 over 2 multiply by. And then here we're going to have what? We're going to have c e to the power of negative x squared. And therefore, this will be our final answer explicitly. This is implicit form, and this is explicit form. Therefore, this will be our final answer. Okay. Do we maybe have... So now let's have a look at this example, right? We have our differential equation, which is t dy dt minus 5t is equals to y. Now look at this equation. Your dependent variable, it is still y, but look at the independent. Be careful, it's t, no longer x. You see? So now here's the thing. When you are given a differential equation like this, you want to check which technique am I going to use to determine the general solution of this equation. Which technique am I going to use? And then you look at your equation and you be like, can I use separable? No, this one here, separable, it won't even work. We can try it. If you want us to try it, it won't work at all. We won't be able to separate t's, we won't be able to separate y's. This, it won't work. I can see it by just looking at it. Right? So that means the only way to do this, can we work with linear? So this is not the standard form, okay? Number one, dy over dt, it is multiplied by t. It's not. It's not it. It's not. This is not. It's not it. So try to rewrite it in a standard form so that you can make correct things. So the standard form, remember I'm writing it there, dy dx plus py is equals to q, right? If you want to use linear. So let us try to make this equation look like that. And remember, this is supposed to be the independent variable. But in this case, be careful. We don't have dx. Even in the standard form here, you can just write dt, dy over dt. But you still need the independent, it's still y, okay? That's fine, that's good. So that means I'm getting rid of this t. That's what I want to do first. It's the fine. So I'm getting rid of my t. So now when I divide by t, t will cancel. And therefore there I'm going to have 5, t will cancel. And then here I'm going to have negative y over t. Right? Now look at my dependent variable. Look at my dependent. Now I'm going to have to take this side because it's my dependent variable. I want to write this equation like this, right? So that means I'm saying dy over dt. What am I doing now? What am I doing? Dy over dt. I transpose this, it becomes positive, right? It becomes positive. Remember, what did I say to you? It's fine, you can write y over t. Now I love writing it like this. It's going to be positive obvious when it comes to this side of the equation, but I'm going to rewrite it like this, 1 over t multiplied by y. It is still the same thing. It is still the same as y over t. I just love expressing it like this. Don't be confused. Is equals to, and I take 5 to the other side of the equation, it becomes positive 5. Now look at this. Dependent, dependent. Be careful. Make sure that this matches with that. If here it's y, there's supposed to be y. If there's theta, here's supposed to be theta something. Okay, be careful about that. Now, remember I said here It could be constant like 5, like it is a constant, or it could be x, but it's not supposed to be y. It's not supposed to be dependent. It's either here it's a constant, just a number, or it's x. Immediately when you see y, it is not a linear equation, it's non-linear. So now, what is the value of p? Again, the value of p in this case, remember, it is the coefficient of dependent variable, which is 1 over t. And then our q in this case, it will be positive 5, right? Right. Now, remember, what is the second thing? After writing p and q, we want the integration factor, right? And then we said our integration factor, it is letter r. Now, integration factor is given by e to the power of integral of p dx, right? So that means we're going to have e integral of p, it's actually 1 over t. Ah, where's my mistake?
Your mistake there,
Where's my mistake?
dx, it should be dt, because
Aha.
the thingy, the independent one, it's dt now, not dx.
I love that. I love that. You see, it's okay to make mistakes when you practice, okay? Not in exam room. So this is what I've been saying. I can also make such a mistakes. This is how I get my marks wrong. But you need to be careful. Sometimes we forget. You just used to dx, dx, dx. You see? So now here we're supposed to write dt. And I've been emphasizing on that. You see? So this is a good example that I made a mistake. It's actually good that I made that mistake so that you guys can be familiar with that. Now, what is the integral of 1 over t dt? So the integral of 1 over t, remember, 1 over x is ln x, natural log, right? It's going to be natural log of t, that's it, plus c, but we don't write that here. And therefore, be careful, ln of natural log t is going to be your exponent. Remember that e to the power of ln x is x, okay? You can prove it with your calculator. You can just say e to the power of 2 ln 2, your answer is going to be 2, okay? It's a basic of mathematics. You make sure that you know that. Can take 2, can take 5, 5 is fine, any number, you're going to get the same answer, okay? So now, that means our integration factor will be equals to t, right? And then remember, repeat q, it will be equals to 5. Now, what is the second step? The second step is to write the formula for this linear. So remember, we say integration factor independent variable multiplied by integration factor is equals to the integral of integration factor multiplied by q d what? dt. Yes, dt, not dx now. Okay? That's why I kept on emphasizing, because you can make mistakes. Now let us substitute our integration factor. We said it's t. We're going to write t there. So we have y multiplied by t. Integral of our integration factor, it's t. Our q, we said it's 5, right? dt. Now we have y multiplied by t is equals to, we take 5 as a constant outside of the integral sign, and then we have dt. This is simple. To integrate this, we know we don't need u substitution, we don't need by parts, we just do the direct integration, right? We use the table, here's where we're going to use the formula sheet, right? So that means we have yt is equals to 5. Remember, according to formula sheet, when you integrate something like this, you add 2 there, and then you multiply by that 2 as a 1 over 2, and then we have t squared plus c. This is the final answer. We are done. Implicitly, explicitly, this will be the final answer. 5 over 2 t plus c over t. This will be the final answer, explicitly, implicitly. If you leave your final answer here, no problem, you are done. As long as they never say make y subject of formula, or as long as it's fine, because the aim is to integrate. You have the differential equation, you have your solution, which is algebraic equation. From here to here, what did you do? We integrated. Here, this is the step where we integrated. But how did we integrate? We used the linear method to integrate. Last time, We were given differential equation. We integrated to get the algebraic equation, which is the solution. But how did we integrate? We use separable, you see? We use homogeneous, you see? We use Bernoulli, you see? We integrate, but the way we integrate is different. It depends which method do we use. But you have to understand that you don't just pick any method because you have to. You pick any method depending on the basics and the rules that we have learned, how to spot the differential equation. Therefore, this will be our general solution since well, it has C. It is not a particular solution because we were not given the conditions. If we were given the conditions, we substitute Y, we substitute T, we solve for C. After solving for C, we come again, we substitute that C that we solved. Maybe it's 2, we write 2 over here. Now we have the particular solution. It's no longer the general solution. I hope I was clear on that one. Oh my God. Now we are on the last question, last example actually of this, right? We have to integrate this. We have to determine the general. In fact, because we are given the conditions now, what are we going to determine? We are going to determine the particular solution, right? Then the question is, how are we going to do that? How are we going to determine the particular solution? Now, this is what is happening. I'm telling you, like, this is linear, okay? Sometimes it's hard to tell, but I don't know which way to explain this to you so that you can see these things. But sometimes it's gonna be hard for someone to tell this is linear, homogeneous. Sometimes it can be hard, okay? But try to analyze, try to check, be quick in your mind. If I try to do this, would this work? If this doesn't work, you understand, because you don't want to waste time. But this is linear. But the thing is, let's try to write it in a standard form first. Or if it is in a standard form, we are fine with that. And then have a look at your dependent and your independent variables, guys. Theta, it looks like dependent variable. So if I were to write this equation in a standard form of linear, therefore I'm going to have to be like, this is d theta over dt plus p theta. Remember, this is supposed to be cousins. They're supposed to match, so it's supposed to be twins, actually. Is equals to Q. This is what we need to do. Right. Let's go to the equation and see if it's gonna be like this. If we take this equation and it becomes here, let me tell you this, we are happy. We are happy more than anything. So let's see. Now we know it's linear. So here we have, I'm gonna get rid of this t so that I can have d theta over dt, right? That's the first thing. Okay, sharp, fine. There I go. So I divide by t, gonna divide by t, I'm gonna divide by t everywhere. So when I divide by t everywhere, I'm gonna have d theta over dt plus 1 over t sec t sine t cos t, close bracket, theta. And in this side, I'm also going to divide by t, right? Because it's the equation. What you do on the left-hand side, you're supposed to do it on the right-hand side. We've been seeing that since from grade 1. So that means, okay, sharp, fine, we are happy. We have d theta over dt. That's what we wanted. And then everything looks happy. Actually, this is the standard form. Look, we have theta there. Let me change it. Let me do this so that you can see. We have theta there. We have theta there. We have p there. We have p there. And then that will be q. This will be q, and this will be q. So that means this is a linear equation. Look, it's a linear equation. Because here, remember, we are not multiplying. We have 1 over t sec t. This is independent. It's not the dependent. You see, if there was dependent, it was going to be non-linear. Therefore, what you're going to do here is what's going to fail. That's why in Bernoulli is the same as linear. Bernoulli is just that we're going to have to force it to be linear. You will see how. So that means in this case, what's happening now? In this case, so far we are happy. We see that blah, blah is blah, blah. But you know what I want to do? This is not tidy. Let's tidy this up. Let's distribute this inside of the bracket. We'll leave theta over there. We're gonna just, we have d theta over dt plus 1 over t multiplied by t will cancel. Sec t multiplied by sine t, it will give us sec t sine t. 1 over t sec t multiplied by cos t, it's going to be 1 over t sec t cos t, close bracket, multiplied by theta will be equals to 1 over t sec t. Do you know that this is the value of p, right? Inside of the bracket is the value of p. And at some point, we're going to have to integrate this p. Remember, when we are looking for integration factor, because we use p, we're going to have to integrate. So having a look at this, can you integrate something that looks like this? No. So my advice is keep on simplifying this until it gets simpler to a point whereby you can see, now I can integrate this. So we have d theta over dt. I'm still continuing with this. Now, here's the thing. Guys, your basics should be on point. Ne? We can see that we have sine t multiplied by sec t. From the basics, this is what you know. I'm going to take you to high school. You've learned saw, ka, toa. I know you know this, right? Sine, cos, tan. And then grade 10, you've learned what we call the inverse of trigonometric ratios, which is cotangent, secant, and cosecant, right? So this is a trick that I used to give. I said, if this is Sogatoa, what will be the inverse? Body cosec, body sec, body. I call them chosha cow. Ne? It's cho. It's the inverse. You take this side. Sha. You take this side. Cow. It's chosha cow. So Sokatoa, it's sine cos tan. Chosha cow, it's cotangent, secant, it's cot, sec, and cosec. Ne? That's how it works. So the reason why I'm doing this is because I want you to understand that this, it goes with this guy. This, it goes with this guy. This, it goes with this guy. Ne? Sine goes with cosec. Ne? Cos goes with sec. So because here we have sec, cos sec, cos is the inverse of sec. Ne? So sec t, which is s cos, is the same as 1 over cos t multiplied by this sine t. I hope you saw what I did over there. Plus 1 over t. What is sec? We now know that sec, it is the reciprocal of cos, right? Which is going to be multiplied by 1 over cos t multiplied by this cos t, close bracket, theta is equals to by 1 over t multiplied by 1 over cos t. Right? Right. Now let us simplify this further. We have d theta over dt plus, what is sine over cos? Is tan. We know that it's what is this thing? It's identity, right? Sine theta over cos theta, we know that it's gonna be tan t, not theta, sorry. Sine t over cos t is gonna be tan t, right? And then look at this. This cos t will cancel that cos t, and therefore on this side we're gonna have 1 over t multiplied by theta. Look at this, how simplified now. Is equals to 1 over t cos t. Now we are happy. We can work, like we don't need special cases to do whatnot. So now, what is our value of p? Remember, our value of p will actually be equals to 10 t plus 1 over t. And then q will be 1 over t cos t. Let's talk about the integration factor. Still repeat the same thing over and over again, which is r is equals to e, be careful, integral of p multiply by dt is going to be equals to E integral of what is P? I'm gonna write it like this because whenever we have two, it's tan t plus 1 over t. I'll just separate them because we know at some point we still gonna have to separate them. I don't wanna do long steps. So I have tan t plus dt plus the integral of 1 over t dt. You see, I just separate them. It's fine. You can just write it like this, but I just want to separate them like this. I hope you understand. But if you don't, you can ask. And therefore, now let us integrate. What is tan t dt? What is the integral of tan t dt? Refer to a table, guys. Tan t dt, it is there on the table. From last year's table, it's rule number EMA1. I don't know EMA2. I've never used that thing, but you can still use it. Tan u, it's ln sec, okay? So we're gonna have ln sec t, right? Oh, my writing. Ln sec t. And then what is the integral of 1 over t? This one, we know it is going to be ln of t. We are done. And therefore, remember, we have E ln sec t multiplied by E ln of t. Remember, what is E ln sec t? It's going to be sec t multiplied by what is E ln of t is going to be t. So that means our R will be t sec t. Repeat, Q will be 1 over t cos t. Then we go back. We're going to say y multiplied by integration factor is equals to integral of integration factor multiplied by q dt. Where did I make mistake? I see my mistake. Where did I make mistake? Guys?
You mean on the let me one
This
sec.
equation. This.
Which one? Where you? Oh,
Where did I make my mistake?
RQ.
Mahlangu? Guys, this is where I made my mistake. This is where I made my mistake. You see, it's theta, not r. Remember? You see?
I was still trying to think.
You see? So be careful, guys, please. So more especially when it comes to applications. You see what I'm doing right now? We're still gonna do this thing under applications, exact same thing, just that we are now applying them. And this is where I think here it's better. You won't make such mistakes, but under applications, you'll even forget that here you continue to why. I get we are used to why. So be careful, be careful. And that's what the lecture even said, okay? Right. So now we have theta, our integration factor, it's t sec t is equals to the integral of our integration factor, it's t sec t multiplied by q, which is 1 over t cos t dt. Do we need a special case to integrate this? No. But I wonder if you are smart enough and you are not lazy to write, you can see that sec, we said it's actually sec, it's actually 1 over, what am I doing now? Or you can change, look, it does not matter, okay? It really does not matter. It's either you change your sec, or it's either you change your, what is this thing, your cos. At this point in time, it does not matter. Whether you change this to sec or you change this to cos, it really does not matter at all, okay? It does not matter at all, as long as you do the right thing over there. So let's change this to, let's change king cos to sec sec t. We know that 1 over cos t is the same as sec. Be careful, we have, oh, by the way, I don't know why this thing is even so slow. This is what I want to do. All right. Okay, so this t will cancel with that t, okay? Because it's 1 over t and we are multiplying. It's a dot. T, this will cancel 1 over 2, and then we left with sec t. And then here we have 1 over cos t. 1 over cos t is the same as sec t dt, okay? All right. And if we have theta t sec t will be equals to sec t multiplied by sec t will give us sec squared t dt. And then there is something like this. There is the integral of sec squared t on your formula. Ne? It's from the last years, it's formula number 10. No, I'm lying. Formula number 13. Sec squared u du is the same as tan u plus c. So that means this, we have theta t sec t over there, and therefore sec squared t will be the same as tan t plus c. Therefore, therefore this is your final answer. But in which form? Implicit form. If you want to do explicit, divide both sides by t sec t and make theta the subject of the formula. That will be explicit. I'll just end here because this is the final answer. If it is not, oh, it's not final answer, I forgot. So this is the general solution. Remember, we are given the condition, right? Oh, I forgot you have the condition. We are given the condition. So what are we going to do? We're going to substitute where you see, and make sure that your calculator, it is in radians all the times, please, okay? So now, we have, let me see. We have, oh my God. We have theta t sec t, which is equals to tan t plus c. And then remember, they say to us, t is theta, right? I mean, it's pi, and then theta is 1. So here we have 1, and then here we have pi. Sec pi is equals to 10 pi plus c. And therefore, we have pi. Remember, this is the same as 1 over, because you don't have sec on your calculator. You have 1 over cos pi. Let me transpose this one. It's going to be negative tan pi is equals to, we left with c on this side. So punch this on your calculator. Ne? So when you punch this on your calculator, you're going to get negative pi is equals to c. Therefore, you're going to say theta t sec this is going to be equals to tan t minus pi.